Hi, everybody. We're going to do problem number 7 on the worksheet, which is the how many milliliters of 5 molar acetic acid are needed to provide the same number of hydrogen ions as 10 milliliters of a 0.015 molar nitric acid solution. I'll do the nitric acid part.
I guess I'll do the acetic acid.
I picked the nitric acid because I recognized nitric acid right away as a...
You picked it because it was easier.
Yeah, no, because it was a strong acid, and strong acids are always easier to deal with than the weak acids. So dealing with my nitric acid, here's what I know. I have 10.0 milliliters of a 0.0150 molar H. That's not easier if I can't write the formula right. HNO3 solution. I'm going to go ahead and take my molarity and my volume, and I'm going to figure out the number of hydrogen ions. I'm going to do it in the units moles. So I could do this one of two ways, right? I could either use the molarity formula, which we do a lot in class. So instead, I'm going to go through and do this through unit analysis.
I like that way.
Mm-hmm. Just to demonstrate that it is possible to do the whole thing in unit analysis. Here's the step that everybody always has trouble with unit analysis. This is where the molarity goes. Every 1 liter of solution will contain 0.0150 moles of HNO3. Now, as it turns out, I'm going to just carry this one step farther just to be really, really, really clear. According to my equation up here, every 1 mole of HNO3 is going to split apart into 1 mole of H plus ions. And so when I go through and do this, I end up getting
Hang on.
1.50 times 10 to the... No, I was waiting for you to... I was stalling for you to give me an answer.
Oh, sorry. He was I'm stalling.
Times 10. So divided by 100. 1, 2...
He'll get it in his head. Yay, you got it right.
That's right. That's moles of H plus ions.
All right, so if you read the question, then this number of hydrogen ions is what we're now kind of being asked about. We want to find out how many milliliters of acetic acid will also provide that many ions.
But Mrs. May, here's what I would really like to see as we go through this problem from all of the people who do this problem is to acknowledge that this is an equilibrium situation. And when dealing with equilibrium situations, we still do that 4-step process.
4 steps. So acetic acid, or you could write HAC like I did in class because I'm lazy, but I'll do the whole thing. All right, so 4 steps. So we got the first one.
Love it.
Our equation. Our second one, I'll do the Ka is hydrogen ion times acetate ion over, see, I'm trying not to write HAC.
So step 2, K expression. Step 3, ice table. I like how you do that. You use the equation. That's really clever.
I always use the equation.
I don't do that.
I totally don't want to rewrite that again.
Save time. So initially we know the molarity of the acetic acid, the HAC as you call it. Or
5 molar given in the problem.
Mm-hmm. We'll say 0 and 0 for those suckers.
All right, so we lose some, we gain some?
Mm-hmm. Win some, lose some.
All right, so we fill out our ice table. Oh, look, and we can do some math.
And let's plug into the K expression. Now, go ahead and plug the whole thing in, but then let's make it easier on ourselves after you've plugged the whole thing in.
All right, x squared over 5 minus x.
But the 5% rule here in our acid-base world says, ooh, if I can change colors, wouldn't it be nice if we could get rid of that? And so we try it.
Oh, now I have to do some math. Why am I the one with the calculator? I have times 5
equals
square root of that business. Oh, x squared. Oh, 9 point.
10 to the negative 5th.
Well, I think we should at least do 9.0 times 10 to the 5th because this has 2 sig figs.
No, 9.0.
Oh, so yeah. Here's our square root, 0.0095.
0.095. Molar would be my x, right?
But are you allowed to do that?
I don't know. We'll be okay. Let's find out.
So,
is it less than 5%?
So a little check on that 5% rule. You need to find out if this number is less than 5% of that, which you might be able to eyeball at this point. But just in case you can't, 0.0095, you don't have to necessarily write this down, but you should check it. You know, you want to find out, is that in fact less than 5%? And I know it is, but I don't know what the number is, so let's see. Oh, it's 0.19%. So is that a valid thing to do?
Yeah, that's
Okay.
good.
Fabulous.
So at this point, we have two halves of this problem. One half that dealt with the nitric acid, where this was the moles of H plus ions, and one half that dealt with the acetic acid, where we just solved for the fact that the molarity of the H plus ions in this solution are 0.0095 molar.
So if I know moles and I know molarity.
Molarity equals moles over liters. So 0.0095 molar equals 1.5 times 10 to the negative fourth, right?
I don't know. I was pretty impressed you had that memorized.
Moles. Yeah.
Well
I got
done.
it. Over X liters. This is what they asked me for. What's the volume of this solution? How many liters, basically? And I think if we plug this in, we get X equals 15.8 milliliters, which to 2 sig figs.
Which incidentally you get in liters,
Oh,
but
sorry.
need to convert. But it's okay.
Let's do that actually. It's 0.0158 liters.
But like we had this conversation earlier. So, which is looks like 15.8 liters, but 16 milliliters because we were limited to
Just
2
2
sig
sig
figs.
Love it.
I think that's the end.
Yeah, that's a good problem. There's
Hey,
a
we
lot
got it
of
right.
moving parts on that problem.
Fabulous. All right, we're done.